So the next is elastic collision in 2D. The next is elastic collision in 2D. So in elastic collision in 2D, bodies collide with each other. Like this is first body, this is second body. They are moving in some direction. This is M1. It's moving with velocity U1 along x-axis. It collides with another mass moving with a velocity U2. After collision, M1 and M2 collide with each other. This is during collision. This is before collision. This is during collision. Then after collision, both the bodies move perpendicular to move at some angle with each other. So the first particle is moving in this direction. The second ball is moving in this direction. So in this sense, this is 2D, that after collision, both the bodies move in different directions. It's moving here with a velocity v1. This angle is θ1. This is moving here with a velocity v2. And this angle is θ2. This is m1 and this one is m2. This is it. Now we can take the component of these velocities, like along this direction, the component of velocity v1 is it's v1 cos θ1, and perpendicular, this is v1 sin θ1. Similarly, you can take component of v2. Along this direction, this is v2 cos θ2. In the perpendicular direction, it's v2 sin θ2. This is it. For elastic collision in 2D, you have to resolve your velocities along x and y axis. So along x axis, the components are v1 cos θ1 and v2 cos θ1. Along y axis, the components are v1 sin θ1 and v2 sin θ2. Now, since the collision is elastic, so both the laws of collision, like both the conservation laws, the conservation of momentum as well as conservation of energy, both are applicable. So if I using conservation of momentum, if I use conservation of momentum, then this says momentum before collision is equal to momentum after collision. But before collision, your momentum is along x-axis, and after collision, it is along x-axis as well as y-axis. So you can apply this conservation momentum separately along x and y-axis. So if I apply conservation momentum along x-axis, so velocity along x-axis is m1u1. Of second mass along x-axis is m2u2. After collision, the velocities are m1v1, it's cos θ1, m2v2, this is cos θ2, cos θ2. This is my first equation. Similarly, you can apply this conservation momentum along y-axis. See, there is no component of velocity along y-axis. So initial momentum along y-axis is 0. Yes, Abdullah, you were correct. After collision, this is m1 v1 sin θ1. And see, if I'm taking this upwards direction as positive, then the downwards would be negative. This will be m2 v2 sine theta. This is equation number 2. So this is the conservation momentum along x as well as y axis. The next thing is we can even apply the conservation of kinetic energy. The collision is elastic, so kinetic energy will remain conserved. So if I apply conservation of kinetic energy, if I use conservation of kinetic energy, yes, Fazil, I'm coming to the example. Plenty of examples of this type of collision. Since the collision is elastic, so both momentum as well as energy is conserved. Now, since your kinetic energy is a scalar quantity, so no need to resolve your kinetic energy. You can just calculate kinetic energy before collision and kinetic energy after collision. This different directions of velocities will not affect kinetic energy. Kinetic energy isn't a vector quantity, it's a scalar quantity. So before collision, your kinetic energy is half m1 u1 square plus half m2 u2 square. After collision, your kinetic energy is half m1 v1 square plus half m2 v2 square. See, kinetic energy is not a vector. Sorry, it's not a vector quantity, it's a scalar quantity. So directions does not matter while calculating kinetic energy. So you need not resolve these velocities while calculating kinetic energy. Now, these are the three equations then we can use in elastic collision in 2D. You will not get any single formula to calculate final velocity. To calculate final velocity in numericals, you have to use these three equations. So the example of this type of collision is like it's snooker. This is one ball. Its mass is m1. It's moving with a velocity u1. This is another ball. No need to write velocities. Let's say this ball is here. This is second ball m2. So this is moving in this direction. This ball is moving in this direction. They collide with each other obliquely. Obliquely means if this is first ball, this is second ball. They collide in this way. After collision, they will move in opposite directions, like in different directions. This will go here, this another ball may go here. So in snooker, the collision that you usually encounter is collision in 2D. Yes, Fazil? Clear?
Yes.
On the pool table, whatever collision you observe, that's two-dimensional collision. There's rarely a one-dimensional collision. On pool table, there's always two-dimensional collision. So this is one example. Okay, so let's erase it. Then instead of elastic, if I ask you to calculate inelastic collision in 2D, Fatma Farhana, can you guess the changes in calculation? What change will you make to if the collision is inelastic instead of elastic? Yes, Fatma Farhana. If I say this is a two-dimensional collision, but instead of elastic, I call this as an inelastic collision. So what change would you observe? What is the change in the calculation? So if your collision is inelastic, then your kinetic energy is not conserved. Only first two equations are valid. Just note it down again. If your collision inelastic, then everything will remain same. Only the last equation, conservation of kinetic energy, will not. The next question is this one. Let's do some questions on this elastic collision in 2D. The question says show that, and this question has practical application in snooker game. On pool table, this question has some real practical significance. The question is show that if body of mass m moving mass m collides elastically with another identical body at rest, then after collision, they will move perpendicular to each other. They will move perpendicular to each other. So the question basically says if you have a ball of mass m, and by the way, this is the logic through which the shots are decided on a pool table. Then after collision, both the balls will move perpendicular to each other. So see, this is ball of mass m. It's moving with some velocity u. This is another ball which is at rest. So it's u1, u2 is 0. They collide with each other, and after this is before collision. Then after collision, they will move perpendicular to each other. Means they will move perpendicular to each other. This is V1. This is V2. This is mass M1. This is mass M2. This is theta 1. This is theta 2. You have to prove that theta 1 plus theta 2 is 90 degrees. And this is what actually happens if you collide two balls, two identical balls, one moving with a velocity u1, another at rest, then after collision, they will move perpendicular to each other. But the thing is, the collision should be oblique collision. Oblique collision means if this is first body and this is second body, then the collision should be this way. It should not be head on. It should be oblique collision. So if this is body of mass m, this is another body of mass m, it's moving here with a velocity u1, then the collision should be sidewise collision, not the head-on one. Like Collision should not be head-on collision. It should be sidewise, oblique collision. If it happens, then after collision, they will move perpendicular to each other. This is what we observe physically on a pool table. Because on pool table, the balls are very smooth balls. The friction is almost negligible. So they always move perpendicular to each other, almost perpendicular. So to prove this thing, we can use two laws. One, conservation of momentum, another, conservation of kinetic energy. Okay, tell me, momentum is a scalar or a vector, Fatma? Momentum is a scalar quantity. It have direction. That's why we were resolving momentum along x and y axis. So if I use conservation of momentum, then conservation of momentum says momentum before collision. I'm using conservation of momentum in proper vector form. M2 U2, which is basically 0, is equal to M1 V1 plus M2 V2. Now, since balls are identical, so M1 equal to M2 is equal to M. So instead of both M1 and M2, I'm using M. So it will be MU1 is MV1 plus MV2. So from both the equations, this M gets cancelled out and you are left with just U1 is V1 plus V2. That is my first equation. If I use conservation of kinetic energy, then conservation of kinetic energy is half M U1 square. The second body is at rest, so kinetic energy is 0. Final is half M V1 square plus half M V2 square. This half M will cancel this half M, it cancel with this half M. And we are left with U1 square is V1 square plus V2 square. That is equation number 2. Next. If I substitute equation number 1 and equation number 2, just one more thing. If I'm writing that U1 square is V1 square plus V2 square, that simply means U1 square is the square of a vector is dot product of vector with itself. U1 square means dot product of U1 with U1. This is the square of a vector. I call this as equation number 3. Just U1 square. I substitute the value of U1 from equation number 1. I'm substituting 1 in 3. So I would get that U1 square is, it's U1 dot U1. That means, what is U1? U1 is V1 plus V2. V1 plus V2 dot V1 plus V2. I'm repeating this step again. If I'm saying that I'm taking square of one vector, then the square of vector simply means dot product of vector with itself. So if writing U1 square, that means dot product of V1 plus V2 with V1 plus V2. So you can just write this as U1 square is take dot product of V1 with V1 is V1 vector dot V1 vector. Take dot product of V1 with V2. V1 dot V2. Dot product of V2 plus V2. So this is distributive property. Dot of V1 with V1, dot of V1 with V2, dot of V2 plus with V1 and V2 with V2. So this is U1 square. V1 dot V1, the dot product of vector with itself is the square of vector. This is V1 dot V2. This I will write as it is. This is V2 dot V1. So in vectors, then the dot product of vector, if I do A dot B or I do B dot A, they're the same thing. A dot B is equal to B dot A. So that's V1 dot V2. V2 dot V2, we can write this as V2 square. That is equation number 3. Now, we can just substitute 3 into. If I substitute 3 into, then this is V1 square plus V1 dot V2 plus V1 dot V2 plus V2 square is V1 square plus V2 square. So this V1 square will cancel this V1 square, V2 square will cancel this V2 square. Very good, which is equal to 0. So that's twice of V1 dot V2 is 0, right? Or you can write this as V1 dot V2 is equal to 0. Yes, Fatma, you're correct. Fatma Farhana, you're correct. If I solve V1 dot V2, this is simply V1 V2 cos theta is equal to 0. If it is 0, that means cos, see, V1 and V2 cannot be 0. Theta is 0. And by the way, what's the angle between V1 and V2? Just check the diagram. I think it was theta, not 0. This V1 was here. This angle was theta 1. V2 is here. This angle is theta 2. So the angle between the vector is, I can write this as theta 1 plus theta 2 is equal to 0. Theta 1 plus theta 2 is equal to 0. You have to prove basically that the sum of theta 1 and theta 2 is 0. Is it clear now, this step?
Yes, sir.
Okay, if it is 0, so cos of theta 1 plus theta 2 is 0. If cos of any angle is 0, that means that angle theta 1 plus theta 2 is equal to 90. Theta 1 plus theta 2 is equal to 90. So this is it. If dot product of two vectors is 0, that means those two vectors are perpendicular to each other. So this simply proves that if a body moving with some velocity collide another body at rest, then after collision, they will move perpendicular to each other. So this is an important result for elastic collision in 2D. Just note it down. Question. Very simple calculation. So you have one body of mass m, of mass 5 kg. It's moving with a velocity of 5 meters per second. It collides with another identical body at rest. And after collision, they move in different directions like this. 5 kg is moving here with some velocity v1. This angle is 30 degree. Another 5 kg is going here. Okay, can you guess this angle? How much is this angle? So this is v1. This is v2. Let's call this angle as 30 degree. I want you to calculate this angle. How much is this angle? These two will move perpendicular to each other. A body moving with some velocity collides another body at rest, and after collision, they will move perpendicular to each other. If one angle is 30 degree, then for another, the angle will be 60 degree. If I use conservation of momentum along x-axis, then along x-axis, your momentum is, it's 5 into 5. I'm using conservation of momentum along x-axis. Let's say first use conservation of momentum along y-axis. Let's use conservation of momentum along y-axis. So if I use conservation of momentum along y-axis, then I'm left with initially the momentum along y-axis is 0. There's no momentum along y-axis. Finally, the momentum is 5 v1 sine 30 minus 5 v2 sine 60. This is conservation of momentum along y-axis. So this is 5 v1 sine 30 is half minus 5 v2 sine 60 is root 3 by 2. I can take this to the left hand side. So I'm left with 5 v2 root 3 by 2 is 5 v1 by 2. So this 2 will cancel 2, 5 will cancel 5. We are left with v1 is v2 root 3. That's my first equation. So this is along y-axis. Next, we can apply the same conservation of momentum along x-axis. So along x-axis, if we apply conservation of momentum, then this is 5 into 5 plus second body is at rest. So this is 5 v1 cos 30, 5 v2 cos 60. Next, I can write this as 25 is, I'm taking 5 as common. This is v1 cos 30. Cos 30 is root 3 by 2. v2 cos 60. Cos 60 is half. You can take this 2 as common. So you have 25 is 5 by 2. It's v1 root 3 plus v2. If I multiplied it here, this will be 50 by 5 is equal to v1 root 3 plus v2. So you have 10 equal to v1 root 3 plus v2. So that's equation number 2. I can substitute 1 in 2. If I substitute 1 in 2, then I will get T10 is, instead of v1, I'm writing v2 root 3. So that's v2 root 3 into root 3 plus v2. So your 10 is root 3, it's 3v2 plus v2. So your 10 is 4v2. So v2 is 10 by 4. So your v2 is 2.5 meter per second. That's v2, which is 2.5 meter per second only. 2.5? No. Yes, 2.5. If your v2 is 2.5, then I can easily calculate v1. Let's say this is 3. If I substitute the value of v2 here, if I substitute 3 in 1, then your v1 comes out to be 25 root 3 meter per second.